Hello, and welcome to the Link Spring Cycle, Gathering Evidence and Using Summary Tables in Inspire Science Grades 9 through 12. I'm Judy Phelan with McGraw-Hill Education, and I am delighted to work alongside you as you explore this cycle. As a science educator, you have likely guided students in gathering and analyzing data or evidence while doing lab experiments. But summary tables may be new to you as you seek to implement the next generation science standards. Let's begin by asking two related why questions. Why are summary tables used in Inspire Science? And why are summary tables key in helping you implement the 3 dimensions of the next generation science standards? There are 5 key things about summary tables that may help you understand why they are so valuable. Summary tables can make students' learning more visible. They can generate additional student-led questions, which is the purpose of the next generation science standards. They are flexible, so they can reflect your teaching style or your students' learning styles. They can guide a storyline for a unit or help develop a storyline for a unit. And they can provide evidence for students to use as they design and implement their STEM projects. Let's talk a minute about making thoughts visible. I learned early in my teaching career, thanks to some awesome professional development, that the mind processes information most of the time in picture form. When a student says, well, I understand it, I just can't put it into words, that really means that their picture is fuzzy. I have subsequently shared with teachers around the globe that as teachers, our number one job is to create clear, accurate pictures in the minds of our students. So one important reason why summary tables are helpful is it makes students' thoughts more visible. Here are a couple of sample summary tables. Notice that students are sketching what happened in the activity or the video, in the demonstration or the reading. Summary tables can help us analyze student understanding. Research suggests that the best labs are those that provide a revision of or an explanation for student beliefs or experiences. For example, most students know that pumping your legs on a swing makes you go higher. However, evidence may be gathered that just sitting on a swing and pumping your legs does nothing, except maybe make your legs tired. The why and the clues may lead them to thinking that pulling on the chain or the rope of the swing and leaning is what makes them go higher. But again, the evidence may show that this is only slightly effective. Once students experience that it takes both things, they're able to revise their beliefs and frame it within their experience. They're able to sketch it from a physics perspective. And the aha moment that we all live for as educators occurs. Having students use a summary table may lead to more aha moments in your classroom, where students' beliefs are challenged and revised, or challenged and affirmed. The second reason why summary tables can be useful is they provide a place for students to generate additional questions. The entire philosophy of the next generation science standards is to let students ask their own questions about natural phenomena and discover their answers as they do activities or read or research online. As you locate and view sample summary tables in your Inspire Science program, you will see that they are a record of student learning. They're student-led and they draw from many resources. Note the column in which students can post new questions as they do their daily work. Summary tables can be flexible. Although Inspire Science provides a template for a summary table, there is no one certain right or wrong design. I encourage you to explore the other resources in this cycle and design a summary table to reflect your teaching style or your individual students' learning styles. Here we see a variety of designs, and as you begin to plan for your Tinker in this cycle, you will decide on a design that works best for you. Perhaps you and your students will co-create one. Perhaps they will differ from unit to unit. This is your time to tinker with various approaches. One of the goals of the Linked Spring cycles is to promote generativity. Generativity is the premise that productive teachers and learners create ongoing growth through self and shared reflection and iteration. The summary table will encompass the entire unit, which includes several modules. As you review the unit storyline, your growth in this cycle may help you decide whether you will use the Inspire Science unit storylines to guide students in their activities, or whether you will let the activities help students develop their own storylines. There is no right or wrong answer. This is a chance for you to be a pedagogical problem solver and make those determinations. In contrast, the claim evidence reasoning template is presented at the module level. It will deal with smaller, more specific chunks of information and perhaps draw from the module storylines. Comparing the driving question boards, the claims evidence reasoning and summary tables, the DBQ is a place to ask and answer student questions related to the phenomenon questions from each unit, which are depicted at the top question in this chart, and each module, which is the second row of questions. But it has no place to record evidence gathered from a myriad of resources for the entire unit. After the completion of any activity, students may be able to answer a question from the driving question board and enter their answers on the summary table. Thus, the question board may diminish while the summary table grows. Likewise, claims, evidence, and reasoning will deal with smaller chunks of information or single activities, and the claims, evidence, and reasoning may become part of the larger summary table. Fifth on our list of why a summary table is included is that summary tables support the unit STEM project. It is here that students gather and apply the evidence that they have. It is the evidence they gathered in each module that they will draw upon as they plan and execute their STEM projects. Now, the STEM project is where students will use that evidence, and they may need to do a little bit more research, but they will enter that STEM project with the summary table as part of what will guide them. So they'll use that evidence. Now, the STEM project always includes the disciplinary core ideas, such as you see here on my screen. Now, we have reviewed at least 5 reasons why summary tables are used in Inspire Science, but now let's take a look at why summary tables are key in helping you implement all 3 dimensions or strands of the next generation science standards. As you take a moment to review one of the NGSS strands, the blue one, consider how a summary table can help you address all 8 of the science and engineering strands. As we saw in the example summary tables earlier, students were doing all of these. Another dimension or strand of the NGSS is the cross-cutting concepts, and they'll be referenced in the teacher edition and student edition. Cross-cutting concepts, much like organizing your sock drawer or arranging your tools in the garage, allow students to have larger categories in which to think about their learning. They feature the main themes of science study, and they can be considered across all disciplines of science. It doesn't matter if you're looking at the structure and function of leaves in biology, or rocks in earth science, or forms of energy in chemistry or physics. Structure and function applies to or cuts across all of these concepts and disciplines. Perhaps you will design something like this template, where students enter the unit question that they keep returning to as they gather evidence. Maybe it will include the STEM title project to remind them that this evidence gathering will ultimately be used for, and the listing of the CCCs to keep one eye on the broad themes that cut across the disciplines that may span the modules of a unit. However you and your students choose to design a summary table, they can help students draw from 3 important strands highlighted in the Next Generation Science Standards, and you are wise to learn to use them before you have students do their STEM unit project. As you seek to grow your skills as a pedagogical problem solver, it requires 3 things. First, a reflection on where you are now. Second, a willingness to try new and different approaches or tinker with approaches you're already using. And an honest assessment of what works and does not work in your classroom as you evaluate your growth. May this cycle help you in all 3 of these areas. You are just finishing your Spark video. Now let's get started with the reflection. I wish you inspiration as you grow your skill sets via this cycle.